coming up to 2 o'clock, so I'll start the workshop. These workshops started off as a 5-day event that we organized last year, and the workshop was part of that. They were actually extraordinarily popular, and we decided to continue with a monthly workshop. Isabel actually gave a workshop in that first session, which was very, very popular and has now been watched over 1,000 times on YouTube. That was very much an introduction to DataWarrior, and today Isabel is going to tell us a little bit more about the capabilities and what sort of things that you can do with DataWarrior. These workshops would only be possible because of the support of all the open source community, but also I think we should mention Liverpool CICAG, who are sponsoring these meetings and help us pay all the licenses and etc. So with that, Isabel, I'd like to hand over to you and ask you to do your workshop. I've put a link to the files that you sent it in the chat for anybody who didn't download them beforehand. Okay, over to you.
Good. Thanks a lot, Chris. I will first try to share my screen. Let's see what's going on. Share. Can you see it?
Yeah, that's great. Looks good.
Okay, good, perfect. So, as Chris said, my name is Isabelle Giraud. I'm working at DataWarrior. It's a Swiss pharmaceutical company located in Allschwil, next to Basel. I've already given a workshop a few months ago. It was in November 2020. And those are the topics I've presented at this time. So I thought it was already quite a lot and not so basic, but then Chris asked me whether I could give an advanced DataWarrior workshop. So, okay, I have tried to make it even more complicated, but don't worry, I'm not sure that I really managed. So this slide I've already presented last time, but maybe it's important to say a word again for the people who did not attend the first session. So DataWarrior is now an open source software, and it's based on the OpenChemLib library. So those two projects, DataWarrior open source and the OpenChemLib, are published. You can find the source code on GitHub, and if you want to contribute, you are always more than welcome, of course. And then on top of that, there is my company version, so DataWarrior's version, which is not exactly the same, but I would say 90% is the same. We have additional access to internal databases and some more tools for assessing the physical properties of the compound, sorry, but not much more. And the developer is Thomas Sander, the main developer of DataWarrior. And he maintains a website which is Open Molecule, and you can download DataWarrior there if you want. I hope you want. So today, those are the topics I would like to show you. The first point is how to use DataWarrior actually to ease your work when you are doing a collaborative work. For example, you are working in open source projects like the malaria project, or you are simply sharing data with colleagues. And for doing that, you are probably, or maybe using Google Sheets or things like that. Then the second point would be completely irrelated. Actually, it's about the Combinatorial Library. Just a small slide here. Yeah. Sorry. How to make combinatorial libraries with DataWarrior, and now in this version there is the possibility to pick reaction in a list of reaction templates, so you don't have to draw or to import the reaction files, but you can simply pick it in the list. Then the third point will be about a small functionality that is hidden into one menu. So in the data menu, there is this add calculated values. It looks like nothing, but actually it's very, very useful to compute more information from your files. Topic 4 will be how to create a library of virtual components once again, but now using the evolutionary library module of DataWarrior and using the FESA algorithm. So FESA is an algorithm which has been developed by my colleague Joël Ball, and it stands for Macro for Enhanced Shape Alignment. Then, because it is important to present your data, of course, I'm going to show you how to use DataWarrior to make very nice visualizations. And because also I am very a huge fan of Inkscape, which is a vector graphic editor. If we have time, I'll also show you how to further tune your drawings into Inkscape. So, okay. There is this menu point we have already a bit seen in the last workshop. Database retrieve data from custom URL. With this function, you can fetch data which are located on a web server. And there are many files actually that are shared through this mean. So you can find text files that are located on the server. You can find a lot of GitHub of files on GitHub. It's a very popular way of sharing your data. And also the Google Sheets, which are very convenient. Then once you have this, when you know how to retrieve this data, maybe you want to include the retrieval into a macro. I'm going to give you a bit, to show you a bit, some examples actually of data that are located, that you can access through DataWarrior and located on a web server. So for example, I've lost my pointer. It's not good. Okay, no pointer. Now it's back. Yeah. So just to show you what kind of data you can get. So I click on the link, it should open a web page. This lands onto the GitHub, onto the GitHub server. And this is the COVID one-shot project of Postera. And they have written a small README text, and in this text you can see that the main file that they are the main file they are providing is called COVID submission all info.csv. CSV stands for comma separated value. If you click on it, you land on this kind of page, and it's still, so the URL here is still not something that DataWarrior can recognize. You have to really get rid of all the HTML of the page. So this is possible when you click on the view row, and this, now you see you have only white space and text. So this means that is really just the text that you can use with DataWarrior. So you copy the URL because it's all about accessing data via URL. So you copy it, and then you go into the software, which I've already launched. And with this many point database, and then retrieve data from custom URL, you just paste your URL, and you maybe you have to pay attention. CSV means comma separated, so you have to change that data format, and that's it. So for GitHub, just remember you have to get the raw data. You click on view raw, and then you get the proper URL. So that's just a warning because there are so many columns in this file. You see, that's really a huge number of columns. That's not very common for DataWarrior files. So going back to the presentation. Another example of data that you can access. Again, it's the Postera company. I have no shares in this company, but and they are publishing now only the activity data on a separate page. And the whole list of compounds is here. So it's very nice, but not so handy to analyze. So you would prefer probably to export the data and use that in another tool. And you can do that with the export CSV. So if you click here, okay, it suggests you to download the data. It's not what we want. We just want to have the link. So you right click and make copy of the link address. Now it's in the clipboard. And again, you can go onto DataWarrior and fetch this data with the same link. Comma separated, it's okay. Now, often you have to access data that are really that are a Google Sheet. I mean, and so it's something that is really interactive. People are publishing their data there. They are adding compounds, removing things, correcting things. So it really needs to be retrieved very often. You cannot rely that you download the data once per week and then it's good. So a Google Sheet URL looks like that. Launching the so again, you see that this URL, it's not only text and nothing else. It's text plus a lot of HTML and complicated formatting. So this cannot be used by the tool. We have to strip off all the HTML, and Google provides an API to do that. So the end of the URL, as you can see, is edit, because you want to edit the Google Sheet. Then it's an hashtag, and then the Google ID specifies which sheet you want to work on. So to make it readable by DataWarrior, you have to export it. So you write export question mark format equal, etc. To make it understandable. I can do that directly here. So it's export first. We want to export it. I hope I won't make a mistake. And then the format for example, and the Google ID is different. Select everything, copy that, and if I click on OK, again, it suggests you to download this data, which we don't want to do, but we have copied the URL, so we can go there and again retrieve the data. So it's deleted now. Okay, so this is how the data is interpreted by DataWarrior. So by default, it always creates these 4 views. I mean, this view is created because it has found out that the file contains smiles. The smiles have been converted into a structure, and because there is a structure into the file, a structure view has been created. And then it also creates some 2D view and a 3D view. So you don't want probably to repeat this operation of editing, copying the URL, going into the database, pasting, etc. So that's why macros comes very handy in. First, you can already notice that we have already some macros at disposal here. If you go into macro, run macro, there is a list here. And one of them is retrieve malaria data. And it's really, the content of this macro is simply a task which fetches the data on a Google Sheet that has been provided by the Open Malaria group. And thank you, Chris. If you want to do the same, so that every time that you open a DataWarrior file, you can run a macro and access your data. So let's say we want to access the antibiotic near-E data. You will have to create a macro first, and then you will have to save it onto your disk on the proper folder. I'm going to show you where it is. So registering a macro is simply by you go to macro, and then you make start recording. You have to give a name. So let's say it's antibiotic. And now, from now on, the tool is recording what you are doing. So you see on the bottom right, sorry, it's written recording macro. And the macro is going to be recorded in the window where you have started the recording. So here it's this window, this data from URL window. So now let's start the job. We go into database. And do exactly the same way as that now. Yes, luckily the URL is still there, so we don't have to change anything. We press on OK. And it's done. And maybe you want to make some adjustments. So you close this view, and maybe you compute some properties. There is a macro to do that, so it's easy. No, that's not good. Yes, I know. Sorry. So this macro is searching for a column named structure, and here it's named structure of SMILE span. So it doesn't find the good column. That's the restriction for macro. It really has to find the proper columns as they have been described into the macro. So we are going to do that by hand. In a way, we go into chemistry, from chemical structure, calculate property, and we calculate the molecular weight, for example, the CFP, CFS, a few properties just to illustrate. And you see that now the structure column is properly assigned to the structure of SMILE span. We have a little bit, 4 more columns here. We are going to use that for the plot here. It's really just to illustrate what you can do. So I will put a column on the H acceptor, for example. Okay, now let's say I'm happy with this look of my data, and I want to stop the recording. And the data, the macro is actually normally located into the original window, this one. And if you go into macro, you see it's present in this window, and not in the window which has been created by my actions. It's really the window where you started the recording. If you want to see what is really recorded into your macro, you just make a new macro editor. And there it shows you what is inside your macro actually. So it's a list of tasks executed in sequence. If you double click on the task, you see what is inside. You can delete some. So for example, select window is not useful because I've just clicked on a window, but it has no meaning. Close view is to close the 3D view. Sometimes double click doesn't work. And then the calculate component property is there. Then I have changed the axis in the view, and I've changed the macro colors. So if I'm happy with that, I'm going to save the file onto my disk. So for that, you go into macro, so export macro, and there's just one, so it's easy. So I have to, let's say I'm going into this one. Macro is here. Note that there is, so I'm going to close a few views because there are so many. So now you have a file which contains the macro, and since for Windows it's I mean for Mac it's the same. So you just have to double click on the file and it's going to execute the macro. So if I double click on it, it's launching a new DataWarrior window. So and it retrieves the data real time. So if somebody changed something in the file in the meantime, it's going to be different. And then it applies, so it closes the view, etc., etc. So if you are happy with this macro and you really want to use that on a daily basis, just to watch and monitor what is going on the project, you may want to save it in a special folder of on your disk. So it's in the application folder of DataWarrior. So what you do, you copy the file and you go onto the installation. So for me, the problem is that I have two installations of DataWarrior, the one for iDosia and the one for the open molecule version, which is a bit different. So I have to, normally you have to put the macro directly into the macro folder of your installation. So this is the installation folder of the open molecule version. You double click on macro, and then you have already some macro that are there by default that come with the installation. But you can add this one too. So you copy it and you paste it there. So for you, this is going to work straight away. I have to copy it also here because of this double installation problem. So if you go back in DataWarrior now, if you go into macro, one macro, you see that this macro retrieve antibiotic does not yet appear because the list is populated only when there is the creation of a new window. So if I just make a new file, a new window, this file new something completely dummy, just to force the software to update this list. Now you see it appeared in the list. You have this retrieve antibiotic data, and every time that you are going to open DataWarrior again, it's going to be there because you have saved the macro into the macro folder. So for Mac users, it's just a bit different because you have to make I mean, the DataWarrior application is in your application folder. If you right click, you can make the package contents appear. So then you will see the different folders, the macro, the plugins, etc. All these folders that you see straight away under Windows. And once you have that, you can store your macro into your macro folder. What is very nice, or maybe it's just a bit funny, I don't know, but I find that quite nice, is that you can simply copy paste macro as text. So for example, let's say you have downloaded just a one. You have downloaded the data from the malaria project, and you have performed a small SRR, and you want to share that with a colleague of you. So you can just send it per chat or per email. Hey, this is the macro I've done. So you copy paste the code. Just try it. So the macro is like that. And actually, let's say you have received that from your colleague. It has sent you this message. You go into your file. So first you retrieve the malaria data. So it's the malaria data with a bit more, with a bit of decorations. So I've created some views. And now you have copied this text, the macro text, and you can simply paste it. Actually, you don't even need to make this selection macro, paste macro. You just have to press Ctrl V, and the software understands that it's the text that has been copied is a macro. And now you see there is a new macro. It's local, so it appears on the top. It's separated by a line. So it is just in your file, and if you run it, it's going to apply this SRR, structural activity relationship. So you are happy, and maybe you say, okay, I will answer. I will make a recording too. I hope it works. I haven't tested that, but so create a new macro. I will just make a filter. And I drag and drop the filter here. And then I stop the macro. I copy the macro. And I can send it to you if I manage. So how do I come back to the? I would like to access the chat. I cannot access. Yes, I need to do that. So, okay, I have sent you in the chat this macro. So if you want, you can test it. You just first fetch the malaria data. So it's retrieve malaria data. It's the one that you have all in your installation. Then you go in the chat, you copy the content, and let's press our finger and make a Ctrl D.
Did you send that message to everybody?
I hope.
Yeah, I'll just make sure that you did.
Did you not receive it?
I got it, but it said it was to me, so I don't know whether it went to everybody. So I put it in the chat to panelists and attendees.
Okay. I don't know. Okay. Well, thank you, Chris. I think it's okay now. Yeah. So that was maybe more funny than really useful. It works very well for small macros. Of course, if you have a macro of several hundreds of lines, it's going to be a bit more cumbersome, and then it's better to just send the file, the one file. Now, in case of a Google Sheet where which is, as I've said, very interactive. So people are updating the file, they add compounds, and how do you spot the changes? So the solution that I'm using is simply to maintain a list of seen data. So you retrieve your data, the malaria data, for example, you import, so you create a list of the data that you have already seen and analyzed, you export this list on your disk. And then the next time you are importing the data from malaria project, you re-import this list and see whether there is a change. So maybe I will try to show you. Maybe I close some window again because there are so many. There should be a close all button without saving it. So where's my file? Okay, I can do it. Yeah, hand, I'd say. So starting again with the malaria data, I've retrieved this data today, 15 hours 30, and I've looked at all this data, and I want to remember that I've looked at all of them. So I select them all, and I make a list. So it's here, list, create a list from the selected rows, or all the rows, visible rows. And that and now we have an additional filter which remembers the list of the compounds. So for the sake of the demonstration, I'm going to exclude a few of them to do, so just to simulate the fact that I have only received, for the moment, there is only 889 compounds, and the next time I'm going to check, maybe there are more, there will be this total amount of 893, so the new compounds will pop up. So the list now, I have to export it on the disk. So I'm going to make a list, export row list. The row list is called already seen as I made it, I have named it like that. And now it's asking for the key column. So what is the identifier of the rows? And in this case, we are going to take the OSM identifier here. And you have to say where you want to save it. So just here, it's fine. Okay. So now we are the day after, so tomorrow, we have tomorrow, and we are going to retrieve the data again and check whether there are new compounds. So retrieve malaria data, and you will know them by heart. And you import the data, the list, sorry. Import the list. No, it was called RSC. Okay. So these are the compounds that I've seen before, and if I invert the filter, you see immediately these 4 compounds have been added in the meantime. Okay, it's just a simulation, but that's how it could work. And on the practical way, it's possible to create a macro for that. So if you simply instead of doing that manually, you can import the macro, the list directly with the macro. So this is now a file, a macro file that does everything automatically. So it creates the visualization, it imports the list, and it inverts the filter so that you can immediately spot what are the compounds that are not seen yet. And if you want to update your list, you select those compounds and say, okay, now I have to add them to the data scene. I know them, and I export the list again. If you want to see the content of this macro, we are going to import it into this file just to see how it works. So I'm going to do import macro. And this was the file that I've used. Again, to see what is the content, you press on the plus button and you create a new macro editor. And then you see what is actually contained into this macro. So in fact, it was a bit more than just visualization. So the first step is getting the data, but then we did a bit of data curation. So there was some cells containing this div divided by 0. So I replaced that by nothing. Then again, low solubility in a column that should contain number. So I removed that. So you can do really also a bit of data curation. Also, sometimes there is a column and we want to have a semicolon for DataWarrior. At the end, I have deleted an empty column. And I have merged all the file data that I found with IC50 values. Maybe this is not exactly professional. I don't know if it's what you wanted. So this creates now a new column, which contains a combination of all these IC50 values. And then at the end, so there are more view configuring tasks, changing the marker colors, etc. And at the end, you have this task that imports the list, which is located on your disk, and that changed the filters to just show the ones that are not part of the list. So if you want to do the same for your Google Sheet or file that are located on GitHub or anything, actually what is important is this task, the retrieve data, and importing the list of the compounds you want to remember, and maybe changing the list to just see the ones that are not part of the list. Okay. As you have seen, the tasks of setting up the views, changing the colors, changing the size of the markers, maybe, etc. That can be a very long list if you want to have, I don't know, 3, 4 views. So it's a bit cumbersome and it really inflates the size of the macro. There is another way to do that. The other way is to use the templates. So in every DataWarrior file, you have the data is organized this way. You have a part which is only the data themselves, so they are naked data. And on top of that, you have a template. So when you get the data directly from your URL with these 4 windows and this greenish color, it means that it has used the default template. DataWarrior has created a template because none of them existed before. But you can replace this template, these views, by another one. And this is just one task. So instead of having 20, 40 tasks for setting up the views, you can just apply a new template. And so I'm going to show you how it works. This is here. So let's say we start with the poster activity data. So that's how they appear when you fetch them via the URL with the default template. And now what you can do is you can change, modify what you want. So change the guys. We can use the IC50 values. Change the color. Okay, it's quite cumbersome. It requires a lot of work. If you want to do that every time, it's going to be a pain. Okay. So let's say we are happy with that, which we are not, but and we want to remember these view settings. So we have the possibility to save now just the view settings and the filters. So we could have put this filter here. You save it, but sorry, just the template. So it's under this menu, File, Save Special, just the template, not the data. And we give it a name. So the next time you run this data retrieval and the file and the data looks like that and it's not yet configured or set up, you can simply apply the template that you have set before. So you go into File, Open Special, and apply the template. And if you select it, you see it's like an additional scheme on top of your data. This template is not so nice. I'm going to use another one that I've prepared before. So again, Open Special, apply template, and I select the one that was prepared for, which is much nicer. So here you can, for example, display the correlation between two methods of measuring the IC50, so the fluorescence IC50 and the rapid fire IC50. And so you can display the different series that are in the file. And you can even split by series, see whether the correlation is better in one case than the other. And indeed, it seems to be the case that in some cases the correlation is better. So if you want to retrieve your data every time with this template, what you want to do is simply to, so I start again from the beginning, I get the data. Oh, sorry. This was an error. First, I have to launch the recording. So I go into Macro, start recording, and we'll say it's the I hope it works. Apply the template. Okay. And I stop the recording. Should be there now. Yeah. I will just check what is inside and make a new macro editor. So first task is to retrieve the data, correct. Then it applies the template, and there you have to select where the template sits, and this cannot be a relative path, it has to be an absolute one. And then here that's not needed, so you can delete it. Right click and make delete the task. So now if you're happy with that, you save it, export this macro on your disk. Window. And last check, you double click on it, and see whether it retrieves the data and apply the template. Okay. So that was for using how you can use a template to very quickly change the visual settings and the filters of your data. So first task, we retrieve the data. Second task, we just apply the template. So now something completely different. The combinatorial library of DataWarrior, the feature.
Isabel, there's a couple of questions, and I don't know whether you're going to be covering these at all. One is, how do you use PCA analysis? And okay, the other is
to be used in, no, yeah.
And the other question is, how do you sort the molecules based on scaffold?
How do you, sorry, I did not
sort molecules based on scaffold?
So how you search for molecules?
Well, it says, can you elaborate how you sort the molecules based on scaffold? It looks interesting.
Okay, so I don't know. Should I maybe either continue the presentation and answer the questions later on?
Well, I was just wondering, are you going to cover them within your presentation?
No.
No. In that case, I think we'll just leave them to the end, and if you have time, then you could pick them up.
Yeah.
Okay, that sounds good.
And the scaffold, I think it's probably how to make a core-based analysis, but
yeah.
Yeah.
And maybe if we could have a break in 15 minutes, just give people a chance 5 minutes to stretch their legs. That would be good.
Yeah, it would be good for me too.
Yeah.
Okay. So try to increase the speed maybe. So combinatorial libraries. I started with loading the data again from malaria, but there I concentrate on 7 compounds. Maybe I show this, the slides also. So we have 7 compounds in the malaria data set that contains this, not scaffold, but substructure. And let's say we want to extend this collection with virtual combinatorial library just to see what is possible to do. So we will generate this combinatorial library, and then we will merge the results with the original file just to see whether we have also produced compounds that already exist in our original file. And then there is the possibility to check whether the compounds, the suggested compound, is synthetically, if you can synthesize it. So for that, we will send the compounds to the Spire website, and they are doing the analysis of the virtual synthesis. So, I just copied this compound for later on, just to have it in my clipboard, because I'm a bit lazy. I don't want to redraw everything. So to create a combinatorial library, you use this chemistry point and enumerate combinatorial library. And either you draw the reaction with these tools, or you load a reaction that already exists, or you can also pick a reaction, a generic reaction that is listed here. And I'm going to use the subjective reaction. And now I have to describe which reactants I have at hand, at disposal. So for the first part, I will use the compound, so not this one exactly, but delete that. Oops. And for these reactants, the other ones, I don't know. So either I would add them from file if I have some file that contains these reactants, or I can let the tool suggest reactions that fit this pattern. So these compounds are coming from the collection of NME, and you can specify some criteria here. So the required, the minimum amount, the maximum price, etc., and how many you want to generate. And then you click on OK. And it's going to generate these hundreds of compounds. So we have virtual compounds here, and we would like to compare. We would like to see whether these compounds are already into the original list. So for that, first we have to be sure that there is only one unique structure per row. That's a condition to be able to merge later on. Actually, yeah, not really. I could keep them, but okay, I will show you how to delete the duplicates. It's simple enough. You have to go into data, delete rows, and you delete the duplicate rows. So for the moment we have 100 rows, 100 products. If we delete the duplicates product, okay, we have lost 4 compounds that were exactly the same. So I'm saving this file locally. And I'm going to append them. So it's in file, append file, and combinatorial library. So what I'm going to do is simply copy all this list of products below this list of malaria compounds. Now the tool asks me whether products belong to which columns, and so I have to tell it should be under the structure of smiles column, and the rest I can create new columns for them. So you remember we have 893 compounds per moment. If I click on OK, I have 100 more. No, not 100, but 96. So now what we can do is merge the data that contain the rows that contain the same product, just to be one unique product per row. So you go into data and merge equivalent rows, and you select product or the structure here, structure of smiles. And then you have again lost some compounds. There is a column which is called dataset name. So it's been created when you have appended the files, which will tell you whether the compounds is only into your original file, the malaria compounds, or whether it belongs to the virtual library, the combinatorial library, or and to the malaria compounds, or only to the virtual library. If you want to see it in a more convenient way, you right-click on the dataset and make a new category filter. So you really see that. So if you want to see the one that belongs to both, so we have created a product that already existed actually. Oh, okay. Let's see. By the way, you have a search, a loop, a multiplying glass that allows to hide all the other columns that you want to find. You know, you just have to type. Yeah. Okay. Yeah, and then if you want to check whether this or that compound belongs can be synthesized, so we are going to just concentrate on the new compound. You pick one and you right click, go into suggest synthesis root of the selected compound, and this is going to open a website. So you have to register first, and your compound is sent to Spyla. So If it is a confidential compound, I don't know, you have to decide. And the tool is now trying to find rules for synthesis. I'm not going to show you how it works because this is outside of the scope of DataWarrior, but at least you know that there is a way to assess whether a compound, a suggested compound, can be synthesized or not. Not the right thing. Okay, we make the break at 4, right? Let's have a look on the add calculated values functionality, which I find very handy. So there are really a lot of functions that you can use when you go into this menu point. I'm going to show you directly. So it's in the under data and add calculated values. And if you click on help, you see the whole list of available functions that you can use. And with this function, you can create a new value, a new column. For example, you could take the logarithmic value of one specific column, or you could just return the square root, or things very simple like that. But there is one function that I particularly like. It's the frequency function, because it allows you to spot in a file whether your compound appears once or twice or three times. How many times you find the exact same compound in a file. So the syntax of this function is like that. So you have to write frequency, and then in parentheses you have the column that you have to pick from the drop-down menu, and then you have to write the exact name of the column. And it's a bit, for me, it was not so clear at the beginning, why do we have twice the same parameter? So I'm going to explain with a file why are these two parameters necessary, actually. So again, I have to find my file. Right. So let's say we have this data set. In one column, you have names of animals, and the second one also names of animals, but not the same. If you want to count how many times bird appears into this column, you can use this formula. So what it means is you are going to take bird and look into the column text. So you are going to take the variable which is in text A, so bird, and look into text A, how many times this appears. And if I do run the macro, let's see what's going to be crystal clear. So I saw that. So you see bird appears twice, it's within 2, dog 3 times. So you have number 3, cat 6, etc. Now there is this other syntax where you can say, okay, I'm looking for something which is in text R, so I'm looking for a dog, but I'm looking for this particular value into another column in text B in this example. So if I run this one, and I will hide this column. So I right click and hide selected column. Sorry, not good. Show the selected column. I just wanted to hide. So bird, how many times did I find it in B? 4 times. So it's number, the number is 4. Dog, how many times did I find it in B. Actually, there is no dog in B, so the number is 0. So, okay, it's enough for this explanation. It just, for me, it was bothering me why there are 2 parameters I did not understand very well at the beginning. So I thought maybe it's the same for you. Yeah, so let's try to use that in a real file. To start with, I'm going to fetch this data, Malaya data, once again. And try to assess whether there are some duplicates of the structures. And to do that, I can also register the macro. Just into data, add calculated value, and I will write put and see. Select the column that contains the structure. Here. So first parameter, it's the one that you select into the list. Second parameter, it's actually exactly the title of your column. So with spaces, with special character, if there are some, really as it is written into the header of the column. And this is the number of so 0 means no structure because the smiles were not interpreted correctly. But you can immediately spot the structure that are identical. So you use the filter. You only want to see those who have a number higher than 1. Where's this? And you can sort them, and then now they really appear grouped by same structure. So since this macro could be very handy, you could save it into your macro folder of the application, I think. I have forgotten to stop the macro, so if I look into the macro editor, okay, there is the function which is useful, but the rest is completely useless. This is the one that I would like to keep. And this will work only if it finds these exact column names, right? So most of the time you are using rather a file that contains columns named structure instead of structures of smiles. So most of the time it's this formula that should be used. And then you could export this macro into the macro folder.
There's a couple of questions which are, I think are related, talking about comparing compounds. So one really question things like, are the free base and salts considered the same, and are stereoisomers the same, or what?
No, it has really to be exactly drawn the same way to be counted of the same structure. But I'm going to show you later on how to distinguish the different isomers, stereoisomers, sorry. Yeah. So maybe that's what people wanted to see.
So if you've got the structure there as a free base and as a salt, they will appear different.
That's going to be different. Yeah. It's really the way the structure is drawn.
Yeah. Okay, that sounds great.
So do you want to make the break now?
Yeah, okay, that's a good idea.
Short break then, because I was a bit slow.
Yeah, don't worry. So if it's 5 past now, so if we come back at 10 past?
Okay.
Okay, that's great. Thanks very much. We'll just, everybody have a stretch of your legs or a drink or whatever.
Yeah.
Okay, we'll see you in 5 minutes. Okay, I hope everybody's had the chance to have a little walk around. Before Isabel starts, I'd like to ask Tammy Warnock just to say a couple of words as the sponsor of this meeting.
Thanks, Chris, and thank you, Isabel, for the excellent workshop so far. I'm Tammy from Liverpool Chirochem. We are a chemical technology innovator on a mission to accelerate small molecule discovery through expanding access to 3D chemical space. Liverpool Chirochem is proud to sponsor this series of workshops as we understand how essential these open source tools are for the global research community. With DataWarrior in particular, it's a software that we use every day, and so we're glad to support its continued development as well as spread the word about LCC at the same time. If you would like to find out more about how Liverpool Chirochem could support your project, please reach out to us on LinkedIn or through our website, liverpoolchirochem.com. I hope everyone enjoys the rest of the workshop. Thank you.
Okay, thanks very much, Tammy. Okay, Isabel, over to you.
Okay, thanks. Back to the sharing screen. Yeah. Okay, you are seeing my screen, right?
Yep. Oh, great.
Perfect. Okay, so yes, I was already, so I've just shown you how to make a macro to count the frequency or to count the number of times you have the same structure in your file. And yes, it really counts the exact same structure, and it doesn't make any makes really a difference between the salts and the not salts and the different still isomers, etc. Now there is another function which is called frequency in category, which is a bit similar. So I'm just going to show you a macro that I've prepared for that, not going into detail, but it counts how many a certain object is in a distinguished between categories. So for example, I've made a macro okay, so this is a data set extracted from the Kendall database, and it's all the values that you find about the JAK1, 2, and 3 targets, the kinase. And what we would like to know is whether, first we want to count how many times we have the same structure. So since the macro is already there, it's easy. You just launch it, and it counts the occurrence of each structure. And one of them is really appears a lot of times, 200 of times. And the other ways would be to find the number of structure in each target. So in this case, we use this frequency in category function. We say we want to find a different structure, but depending on the target. So target name is the category, and structure is the objects we want to count. And a more elaborate macro, I think it's this one, not in difficult. No. Sorry. It doesn't work as I wanted. I will just edit the file. Okay, so no, I think I made a mistake with my files. So this one is just doing exactly the same as we have seen. So it's just counting the structure. Now I would like to show you also how to count to identify the different ISO stairs of the same compounds. I'm struggling with the different folders. So that would be this macro, where we want to identify the enantiomer into the malaria data. So again, I'm going to fetch this malaria data. Sorry, I should keep it in the. I'm going to import the macro I've just shown you. I'm not in the proper directory. And let's have a look what it contains. So it's a bit more complicated than just counting the structure. We have to perform a number of steps before. And the first one is to calculate open the calculate compound property. So if you would do it manually, you have to go into chemistry, calculate compound property, and check into functional group the fact that it will show whether what kind of stereo isomer it is. Then the next task to perform is adding the canonical code. And so, as you may know, DataWarrior describes every structure with an ID code. And now what it's possible to do is to create a canonical code that completely distinguishes the structure. And you can say you want to only distinguish the largest fragment, or you can also distinguish the tautomers, or you can distinguish the stereoisomers. Meaning that if you uncheck this, it's going to give the same code if the main fragment is the same. So source will not be different. And add seed info is not necessary, but then we are counting now the fragment not distinguishing the source or the ISO pairs. That's is going to give us a new column called flat structure. Tells you how many times the compounds with the same flat structures appear. And then we are going to enumerate them to give a number to them. So let's just do it. And see how it looks like. Okay. So now you see that there are some compounds that have the flat racemate, or I'm going to show you that directly into the filters. You have this zip info text where you can select an enantiomer, for example, this one. So this compound here has a stereochemistry which is completely defined, so you know in which direction that points. If you want to find the other one, the number of the flat structure is it has only one similar compound, so we have to find something that has more than one. So this one appears in 2 versions normally, and the number is 5. So let's try to find the number 5. As you can see, it appears in 2 versions, and now we have found his kind of twin, so pointing upward and downwards. So this identify enantiomer macro, what it does, it allows you to group your compounds regardless of the stereochemistry. I don't know if it was clear enough because I struggled a bit in finding the compounds, but if you want me to repeat the explanation. Anyway, the macro is present into your files and you can play it on any other data set. Another function that I find very useful is the fact that the value standard deviation, which actually computes the standard deviation of the values contained in one cell. So when you perform or you get the results of an assay, sometimes you have duplicates. So you have many different values in the same cell. And this gives you an idea of the reliability of the measure. If you have 3 times almost the same value, maybe you can think that it's a very reliable value. So so with these 2 functions, value standard deviation, which calculates the standard deviation in one cell, and the value counts, which gives you the number of values that you have in a cell, you can estimate how reliable a measure is. I'm going to show you that. So this is the file, the original file. As you can see, it's completely fake data. So let's say we have a list of compounds. This is the compounds from the Combinatorial Library I've created. And I've added some fake assay value. But in this case, the compound has been tested 3 times. In this case, it has been tested I think 6 times, etc. How to compute this value in order to display that onto your graph. So you would go into this data, add calculated value, and so always a hard time to remember value standard deviation. So value. You select the column that contains these multiple values. You can even use the whole formula as name. So now you have this standard deviation, which gives you an idea of the validity of the measures. And of course, it's much more reliable if you have many values. So you are going to use the other function, count value. Value count, not count value, but value count. Well, now these 2 additional information can be used to color the dots, color the markers, and change the size. So we want to assign the size onto the number of value. So the less value we have, the smaller the dots is going to be. And we want to assign the color to the standard deviation. Of course, here good values are supposed to be green and low, so we change that. And high value are supposed to be not so good, so green. Yeah. So you have the same information, meaning you have your compounds sorted by the activity on 2 fictional targets. But on top of that, you have also the information whether whether the measurements can be considered as reliable or not. This was a very bad point. Also, it can be that you can edit a cell. Let's say we change something. So there is one more value. Normally it doesn't happen that, or two more values. Okay. So of course now these columns are not correct anymore because they were based on the former computation, but you can recalculate that. So for one it's 29, and if I recalculate all columns, it's going to be updated with the value, with the current values. So it's right-clicking, update formula, and recalculate. I'm going to skip that, I think, because the time is running. I can show that later on if you want. It's a function entry. It's called entry, and it allows to make some data curation in a way to extract information from cells. For example, in this Campbell data set, we have the publication, a field publication, which is the format is like this. You have the name of the paper, and completely at the end, completely at the end, you have the year. And if you want to extract the year, you have to say, okay, I will split this string into 3 parts, and the separator is the parentheses. So by doing that, you can extract the year. And not showing that right now. If I have time, I'll come back to that. Same for this other functionality, increasing category, which allows to actually make the derivative of a curve increase its own. Because I wanted to show you this evolutionary library with Phasor, and we have 30 minutes left, so it should be okay. So this is new in the latest version of DataWarrior. The evolutionary library already existed before, but now we can also use the Phasor algorithm, which has been, as I said, it has been developed by Joël Val. So the algorithm tries to assess whether a compound is matching another one based on the 3D conformation. So you give the two 3D conformation, the conformation of the query and the conformation of the compounds you want to screen. And the tool try to align them using the shape and also using the pharmacophore features. So since I'm completely naive in this domain, I picked an example randomly. So it's still in the malaria domain, let's say. There is the company Genzyme has published structural data on a compound, which is GANS 10-150. So we have the binding position of this compound into the protein. The references are here. The link to the protein database is here. I'm going to send you also this link. So the first thing to do is to extract the ligand from this file. So for that, you can use the tool of your choice. I have used Bimol, but Chimera can do that too, or maybe there are other ones. So the first step, as I said, is to extract the compounds you know is binding to the protein, so in his good conformation. And then you can use that for making a new library of virtual compounds using this functionality build evolutionary library. So I'm going to show you that. Nice, evolutionary library. So the query, this is the ligand I've talked about. It is a dwarf file, but you see that dwarf files can also contain 3D information. So this is the compound in the conformation it adopted into the protein, and we want to remember that. So we want to copy that. So you right click, you make copy structure as, and you select 3D structure. So with that, now we are going to create or to build this library of virtual compounds. It's into the chemistry menu point, build evolutionary library. And so the dialog presence is like that. You have first a set of compounds that you can use as kind of seeds. So the algorithm is going to evolve these compounds. Oops, it's going to make small changes and try to find every time if the changes are profitable or beneficial, and if the criteria you are going to define here are met or not. So now let's define these criteria. You have the possibility to add them here. So either you look for similar compounds, or what I wanted to show is trying to find conformers that are similar to your compound. So here you can input your conformation, the component, the conformation that you have chosen. So either if you right click, either you can load it from a file, or you can also simply paste it. Since we have copied that just before as a 3D molecule, we can use the paste functionality. So now we are trying to find molecules that are similar to this molecule, but just in terms of phasor similarity. So just the shape is similar, and also the pharmacophore should be similar. What we can also add is we want to have actually compounds that are not similar to, I don't know what's going to happen if I paste it to B. No, that's good. It's probably okay. It's just the problem is that it's charged, so it's complaining. So now I would like to create also molecules that are dissimilar to the one. And I can continue adding some criteria like molecular weight should be lower than difficult, just 600. And when I'm ready, I will just press on OK. And yes, you can also adjust the weight. So say that this criteria is really very important for me, or this one, because at the end, the final score is going to be based on the 3 different criteria here. Okay, it really doesn't like that. I cannot. I would have to have this component to a version, an uncharged version, but I cannot modify it. I don't know why.
Perhaps change it to carbon and then change it back.
Just like it. It's a bit. Okay, so I clicked on OK, and now it's probably it's quite slow because it's, I mean, it's all relative. You see that it's already found some good compounds in terms of phase alignment and molecular weight, etc. But it takes some time. So for the moment, we have only the generation 3, and maybe I'm not going to wait until it's completely finished. Just want to show you the result at the end. I prepared some file here. No, so this file contains first the method, how I produced the results. So it's just a macro that contains the same dialog. You see, for this I've just, it's a very simplified seed. I've taken the original compound as a seed, and the rest is the same. So I have just tried to find similar compounds based on the phase algorithm, and find compounds that are dissimilar to this one. And here I've just selected another criteria. And then you see how the compound, how the algorithm evolves the compounds. So in the table, you have the original compound, how well it fits. So probably we wanted to have a dissimilar compound, so a compound that is not similar in terms of structure to this one. So that's why the fitness is not so good. And this is the similarity of the phase algorithm. And this is, if you sort by fitness, so the total fitness, this is the compound which is the one that best matches all the criteria we have defined before. Now, okay, this is already. So let's say we want to assess in our compounds of the malaria project again. So I fetch the data without any computation. 3D computation, sorry. So this is again the naked data. What I would like to do now is compare the conformers I fetched from the PDB with conformers that could be generated by DataWarrior from this data set. So the first thing to do is to compute these conformers. So you go into chemistry, generate conformers. And you can say how many of the conformers you want to have. Not too many. Okay. It's a lot of compounds. So for a moment, the software is generating 5 different conformers, trying to find the minimal energy. And at the end, we are going to try to superimpose the conformer we had copied from the PDB onto those compounds. So for that, you go into chemistry. So generate conformers you already have done. Now you superpose the conformer. And it asks me what is the 3D molecule you want to superpose. So I hope it's still into the clipboard. Yes, it is. So you paste your conformation and you click on OK. And then it gives you, again, a phase score. So how well the best compound for this superposition would be this one. So this is the one that has the where it could really, I mean, it's not a high score, it should be above 0.8, something like that, to be really meaningful. But this is the best it could do. And you can see the superposition here. If you want to increase this, you click on this small arrow, and you can also increase that. And then you can observe where where it was correctly aligned and where it was really not possible to align the two conformance. Yeah, okay. Yes, that's what I've just shown to you. So how to generate these conformers and how to align them. Now, don't know, maybe do you want me to go back to the calculated values, or maybe just show you quickly how to make nice views, please?
I think actually that incorporating in people's presentations would actually be very useful.
Yeah, okay.
Yeah.
Good. So back to that. Okay, we'll start again with the malaria data. Not a surprise. And I wanted to show you how to create such views, actually. So I will start from scratch. When you create a new 2D view, it looks like that. So completely, I mean, it's always the same default color. It's rose or greenish. So you select first on the axis what you want to represent. So for example, this one, and I will do something different. There's no molecular right here. Okay, okay. So to assign the color, you have already seen actually. So you set marker color and then you select maybe the series. And maybe you would like for your presentation to get rid of all these unmeasured compounds. So those compounds are all the ones that have not been measured into the file IC50 GSK assay. For that, you go into the configure view. So it's on the tool option, small button, and then you change that for graphical view option. And this the tab number 3 here, row hiding, allows you to, by default, it shows also the empty values. So this you can disable. And as we are there already, there are a lot of other things that you can do with this set graphical view option. For example, you can hide the grid. You can also change the font size, hide the legend. You could also change the label background, and this is what we are going to do now, because we want to put on each dot the structure. We want to draw the structures as a label, and for the moment it's going to be on a gray background. I prefer to have it white, but it's just a matter. And then you click on OK. So now if we want to represent the structure, for this point, for example, and maybe this one, and this one. One way would be to create a list from this point. So you create a list from the selected rows. And now you go into the set marker labels option, menu point, and you select structure here. So structure of smiles. But you want to show only the one of the list that you have just created. You could also say you just want to have it on the selected rows. The only difference is that if you do that, the color of the selected records is always green. So maybe you want to keep the color. So it's better to just to use a list. And to make it even more nicer, you can put it into a square. You can adjust the transparency of the square, and you can change the size. Now this label is superimposed, but you can drag and drop it like that. You could also have selected, as I forgot to do. Say, okay, I don't want to have it yellow because the structure which is yellow is not so nice. So it's not the good. It's in set marker label, but you can change the color. And here you can say, I just want to have it in black or white. Okay. So now what I like to do is to export that. I'll make a copy view image. And here you have the choice between, if you copy the image to the clipboard, like that, it's very easy in DataWarrior. So I want to make a new slide just to show you how to so I have copied that into my clipboard. If I press Ctrl V or I paste it, I already have it. Right? It's a picture, it's a bitmap. I cannot change anything, but if I'm happy with that, it's all right. Only maybe it can be that you want to make some additional changes. So you want to be able to edit this picture. For that, instead of exporting that as a bitmap, so copying the image to a clipboard or save image as PNG file, that's basically the same, it's a bitmap. But you can also save this image as vector graphic file. So every marker, every label is going to be a separate object that you can change. And then you save the file. Give it the same name here, 2DB. So it's now here. And you see the icon. This is the icon of Inkscape. It's an open source software too. If you double click on it, you can now edit it. So at the beginning, everything is grouped, but you can ungroup the objects. Please Ctrl-Shift-G. You can ungroup further. So now we really have one object that you can even move if you want. It's not the goal, but you could move it if you want. You can modify that if you want to put some more information. You can change the font size and everything can be changed. Okay.
I've put a link to Inkscape in the chat, just so if people want to download it.
And yeah, one thing too, if you want to work with Inkscape, these objects, so the dots, they are actually made of two things. So the background is one object, and the circle around is also another object. So it's easier to work with the picture in Inkscape if you change that. And it's in rendering. So you remove the draw marker, the marker outlines. So now it's really just one object. You have not the second object onto it. And just export it again. I should have shown you that before, but so I'm going to revert the file. So you see the difference. Maybe you don't see that. I want to ungroup everything. And what is also possible, and it's kind of fun, is to change the markers for another. So if you really want to make something that people remember, let's say you want to use these icons and replace some of the dots with the small icons. So you copy that. So I've taken these icons from this website where they are free and in open source. And save that here. I copy paste simply. And let's say this compound is toxic and I want to emphasize that. So I select them both object. And now I'm using these functions. So it's an align and distribute object. And there is this swap object. So it's magic. It has taken the dot and so it has really simply swapped both objects. And you can do that for them. Okay, so this is really just aesthetic, but it's sometimes it's just very useful to convince people. So I thought I would show you that because I'm such a fan of this game. I saved the file, and of course you can delete what not useful. And now again you can copy that, select everything, make a Ctrl+C, and go into PowerPoint and paste it. Also good to know is that directly from DataWarrior, you can copy the structure. Those are here. Copy structure to the structure and paste it directly in PowerPoint. If you right click, and select edit picture, then it's going to be a Microsoft object. So you can now work with that and make a shadow if you want. You can work as if it was a normal object of PowerPoint. So with that, I think I am at the end of the presentation. So if you want, I can go back to the calculated values that I've not shown you, or maybe I can answer questions.
Yeah. There was a question on how do you filter duplicates from a data set? I think you did describe it briefly, but perhaps just go over it because it's something you do quite regularly.
So if you want to delete duplicate, there is either you first try to identify them, so with using this frequency function that we have seen.
Yeah.
Then you select them manually because you want to pick the one that you delete, or just get back to that. What is that? Let's see it here. So in this case, we have some duplicates. If we want to remove them very easily, but blindly in a way, you can go into data, delete rows, and you select duplicate rows. So it's going to keep the first one and delete all the others. I do. So for example, here, if I want to keep only the one that have a measure in vivo parasites, oh no, that's just one. So, when you first sort your data as you want to have them, and then if you make delete rows, duplicate rows, it's going to, as I said, it keeps the first one and it deletes all the others. So you have just to define what is the criteria for duplicates. And in our case, it would be the structure. If we have twice the same structure, then it's going to delete one. And you see that we have reduced the number to, we have lost, I don't know, 9, something like that. Yeah, that's a way. Sometimes you don't want to delete them really, you just want to merge the equivalent rows. So just combine everything into one row, everything you know about the structure, for example. Yeah.
So a merge equivalent rows would, again, it has to be an identical structure. It's not salt forms or anything like this.
It can be for anything, but yes, for salt, it's the same problem. You have first to probably to generate this this code where generate canonical code. Then you say I just want to have one code unique for the largest fragment. So all salts are going to have the same code. And then if you delete the rows using this code that you have just generated, you see that you lose again some compounds because they appeared in their salt form, and now they have been deleted because they had all the same canonical code. So the canonical code, as I've computed it, is unique. I mean, you get the same code for all your salt version.
There's a question, are the PowerPoint slides going to be available?
Yeah, I can send it to you, yes, no problem.
If you sent it to me, I'll just put it in the same place as all the data files and things like that then.
It makes sense because I have some links in that.
Yeah.
We shared. Yeah.
Okay. Well, I think we're almost at time. So I think, again, actually we got really good value for this time. We got a workshop on DataWarrior, but also a brief intro into Inkscape as well, which I can see a lot of people using to annotate slides. It's one of those things that you always remember that there's some little thing that you want to change in an image, and you have to go back to the start otherwise. But being able to annotate the individual objects individually is really very, very useful.
I think it's really great because sometimes you don't want to spend too much time in just fine-tuning, how it looks like. Yeah. This you can do with Inkscape very, very flexible way. Of course, you will have to invest a bit of time learning Inkscape. But
yeah, that's
also
true.
Very good tutorials on YouTube if you want.
So again, thanks very much, Isabel. I mean, again, another really fantastic tutorial. Everybody who's registered for this will get the link to the YouTube video, and when I put it up, which will be sometime next week. But again, once again, thanks for an absolutely fabulous presentation, and thank everybody involved in developing DataWarrior. I mean, I think this is an absolutely invaluable tool, and all chemists should have it on their desktop.
And maybe the very last thing, if you go into the help, so first the help has a very nice find search field that works very well. So that's one thing that's new too. And the second thing is that you can directly go onto the forum. And if you want to ask more questions, or if you have ideas of improving, just feel free to post there.
Yeah, and if you're a programmer, feel free to contribute.
Yes, exactly. That would be great.
Yeah,
Yeah.
I think the macros look very, very interesting. I think we talked beforehand that it might be worth having a forum to exchange macros if people have developed them. So that would be my suggestion at the moment anyway.
Yeah, and I've received also some questions about other types of data that you can access on mind workflows, for example. We are considering the possibility to how do you say, to connect 9 workflows to DataWarrior. It's not yet ready.
Mm-hmm.
This is maybe a possibility.
Yeah,
I had a question about screening millions and billions of compounds with DataWarrior. So that's possible, except if you have a machine with unlimited memory. But there too, the OpenChemLib library, the other project on which DataWarrior is relying, this can be extended, and I think it's part of our future plan to publish a tool that allows screening of large databases. So we'll see.
Yeah. Okay. Well,
Okay.
yeah, that's brilliant. Well, thank you very much, and you should go and have a nice cup of tea or something now to relax.
Thank you.
Okay. Thank you very much. Okay. See you then. Bye-bye.
Goodbye.